Today I'm going to talk about the runtime auto-tuning work that's being done within the framework of Kokkos Tools. We're using Apex as a tuning engine, but as I'll explain, this could really be done with any tuning, arbitrary tuning engine. So in this talk I'm going to try and abstract away the tuning engine from abstract the tuning engine and the mechanism. So let me go into a little bit on just really the right now how auto tuning in Kokkos Tools is. Where it sits, basically. Just a quick, for those of you that, I'm sure that many of you do know about Kokkos Tools, but I'm just gonna quickly review it. Right now, it's Kokkos Tools is a suite of, oops. Oh, great. Did I kick something? Oh, okay. All right, so Kokkos Tools is essentially a tooling infrastructure and a set of tool libraries. And so there's there's utilities, and then there's debugging, and then there's profiling. And so I categorize those, the debugging and profiling, as tooling for correctness and performance. In the tooling library, in the set of tooling libraries, there are so-called manual tools, so things like simple kernel timer or kernel logger, these are tooling from the debugging and profiling sets. And then there's a set of tools that are automated. The category of tools that are automated actually do something. They actually fix the code, fix the Kokkos application at runtime. And that is where auto tuning comes into play. There's been a lot of work that's been done over the last couple of years on integrating auto-tuning capabilities with MD range policy, team policy, whatnot, and then occupancy tuning. So this was started in the release of Kokkos 4.5, but there's I think in the last year there's been a lot more work to expand tuning to be first more to include more tuning parameters. So we're talking about right now Kokkos COM tuning, and then also to use some sort of machine learning guided auto tuning. So this is the key is that the tuning parameters and the tuning mechanisms it's generic and arbitrary within Kokkos. So MD range policy is just one way to tune, but there's just many different kinds of tuning opportunities within Kokkos. What I want to do is just quickly go over kind of the way that or the use of tuning within Kokkos. So if you write a Kokkos application, this is how you would enable some sort of auto tuning with team policy. You can use this -- flag to Kokkos tune internals. What happens inside Kokkos is declaring when you do this auto p team policy and auto, it's declaring the input variables once. And then then it's so what that does is then stores input variables and values and output variables and values. So this happens happens within the Kokkos tools library, and there's something called a tuning API that enables this. And then there's declare output variables once, and then what this does, this stores the output variables, and then there's a begin context. There's a callback in Kokkos Tools called for creating a context for a tuning session, and then from that, there's this exchange between the Kokkos Runtime and Kokkos Tools to request the output variable values, which essentially provide that tuned result. So there's a way to enable this convergence, and this is really key in Kokkos Tools because after some point in time, if you have the best performing parameters, you don't want to keep tuning and incurring the overheads for that auto tuning. So that there's that capability, and then at the end there's this end context. And so that's the stop timing or stop timer that captures that tuning region and the results from it. So that's what happened all within this. I encourage, so what I want to do is just right now, there have been a lot of updates on the tool, on the Kokkos auto tuning features. I just want to put a plug and make sure people know that you can actually use this through a set of different through variety of flags and setup here, and yeah, check it out, and feel free to put a GitHub issue and pull a request on Kokkos Tools if you're on the Kokkos Tools repo if you run into any problems. I'm just gonna mention that, okay, so there are some positive results for using this tool, Apex, so what the key thing I want to note here is that so this is an application timeline profile of a tuning session for Kokkos MapMul. Here, if you look, you can see in this plot these values are kind of changing here and then converging essentially right here. So this is at this point, so these are different tuning parameters, and at this point, basically, you found the best performing parameter, and so at each kernel invocation, it just keeps using that. So there's significant benefits to using this because you're not paying the cost of tuning at each kernel invocation. You are stopping after a certain point, and so the overheads, even though the tuning search might be, say, 30% for certain kernel invocations, we found that kernel convergence is pretty fast. One important thing that I want to bring up is we're working with composable kernels. This is ongoing work. So this is from AMD. The question really here is, well, okay, so we have this tuning capabilities within Kokkos. How can we make use of what's already there in composable kernels and tune different parameters? And maybe also does composable kernels or CK need to be adapted to exposed tuning parameters? So so I'm working with Matthew at AMD on this. So there's different steps that we need to consider for doing the tuning for some arbitrary composable kernel. It's kernel generation, kernel selection. These two are just picking the right the best performing or the right kernels to utilize. So it could be a matmul, but a particular kind of strategy in matmul is what we're trying to get at. And then from there, then you use a combination of offline and online auto tuning, and we would use the Kokkos Tools tuning interface to help to aid in that tuning. And then I'm going to just quickly mention there's a profiling library that so auto tuning right now, because in Kokkos you can take in arbitrary values and then tune given those values. You can actually put in, say, some input of, say, like I/O, or like the I/O usage, or some external event. And so the idea is, so there's something at Sandia called the LDMS, and so the idea is to plug in LDMS into Kokkos Tool, LDMS profiling data into Kokkos Tools, and do the tuning for the based on the performance on this, based on the data from that. And so there's a pull request on Kokkos Tools that I invite you to check out. And then there's some code where I'm using libunwind to gather MPI plus LDMS feedback into Kokkos. And so, so the last point, important point, and then I'm going to wrap up. It's basically right now the Kokkos Tools Tuning API needs some work to handle more goals. So, what about energy? What about memory utilization? All of these vectors, the Kokkos Tools Tuning API could be a little more could allow for more generality, rather than just performance. And then there probably the other thing is the usability. Do we really need to have this, I guess, big N and N context? Some of the there's some naming, and there's some maybe some ways to wrap multiple callbacks into one. I'm gonna skip over. This is just that once we have auto tuning, we can use we can do source-to-source translation and incorporate that into our tuning workflow. And there's some work on Code Rosetta for doing that. I will, for the sake of time, that's it. Yeah.
All right, thank you, Vivek. We're tight on time, so please.